Hi, my name is Craig Nelson, and I'm the Global Sales Exec for Broadcom's Brocade Storage Networking Division. We're here at IBM's TechU 2019 in Las Vegas, and I have with me two luminaries in the industry, and well, more importantly, someone who they both did some really exciting work around a performance paper specific to Oracle workloads and flash system, which is a topic everybody wants to know about. So maybe a little background on why was the paper important to both of you, both from an IBM as well as a Broadcom perspective.
I'm Matt Smith. I'm the Flash System Offering Manager for the 9100. I think that we were really interested in doing this paper to demonstrate the benefit of moving to the 32 gig Fibre Channel technology over the existing 16 gig technology. As a side benefit, we were also interested in showing that NVMe is now becoming a very viable protocol within the industry.
Thanks, Matt. I'm Mark Jones. I'm from Broadcom Incorporated. I work for the Emulex division. My role is I'm the Director of Tech Marketing and Performance for our division. Our reasons for getting involved in this paper were that as we developed our product for NVMe over Fibre Channel, we knew there were huge performance benefits available, ready for us to see if real-world applications could take advantage of them.
I think that's what's going to be most exciting for people. The talk about NVMe or even 32 gig has been PowerPoint-related results, not real-world results. So maybe you could outline, what did you set up for tests?
Yeah, we were really excited to see that the new IBM Array had end-to-end 32 gig Fibre Channel capabilities on it, along with the IBM and Brocade Fibre Channel network switches. So we had two angles that we wanted to attack there, knowing that it's end-to-end 32 gig, and also the first time we have NVMe over Fibre Channel end-to-end. There were two areas we really wanted to go after. First was proving the application benefit in the real world of end-to-end 32 gig. We used an Oracle database and set up a data warehousing environment. And in that environment, we saw that because of 32 gig Fibre Channel, that we're able to do a data warehousing TPC-H-like query that can be executed in literally half the time compared to 16 gig Fibre Channel. The NVMe component really gave us opportunity to see how efficient and fast the transactions could be performed on an Oracle server. So we found in that environment, running a TPC-C-like workload, that NVMe over Fibre Channel both increased performance by 24% over regular Fibre Channel. It lowered the CPU utilization, the I/O component of CPU on the host computers, by a massive 25%. And taking those two things together, the overall efficiency of the host was 3.5x of traditional Fibre Channel. And all this, now that this has been available for a while, all this, we have multipathing available now with ANA support on the array and on the host. And so there's really no reason not to move to this new technology. There's benefits to be had.
So for this paper, you were probably some of the first ones to set up an NVMe and 32 gig test. What was the setup like? What was the environment that you constructed to do this test?
Sure, yeah. So we approached it as we wanted to isolate the performance differences between Fibre Channel and NVMe over Fibre Channel, and also compare the performance differences between 16 and 32 gig. So to isolate that, we kept the environment fairly straightforward. So we used a single host computer that ran SLES 15 SP1, which has NVMe support and multipathing support built into it now, as well as a single switch fabric with a Brocade G630 switch in the fabric. And then on the storage side, we had an IBM FS 9150 all-flash array with 32 gig HBAs in it.
And then that's a newer addition, the 32 gig front end. Is it not on the flash systems?
Sure. Originally, we were shipping with a 16 gig. We introduced the 32 gig a few months ago. I think the interesting thing is the fact that we now support end-to-end NVMe. Obviously, the existing Fibre Channel protocol is very much a single-threaded protocol, and NVMe brings a whole bunch of advantages to the table. It allows much more parallelism in the system, and with the 9150 and the back-end NVMe, we really wanted to demonstrate the benefit of having NVMe coming in from the host, staying highly parallelized right through to the back-end storage.
I think, as everybody says, we've seen a lot of discussion and talk about performance, but it's all been on PowerPoint slides. I think you guys have some real-world results you could probably talk through. So maybe both of you could give a highlight on what did you see at the storage or at the server?
Sure, yeah. I mean, most of the things you've seen have been micro benchmarks, and this is really the first time where we try to translate, those kind of results into something real world. So nothing better than like an Oracle database. So we used Oracle 12c as the database, and we constructed a very large data set on the storage device that was mounted either over NVMe FC or traditional Fibre Channel. And the benchmark we used was something called HammerDB, which simulates a TPCC workload, and it measures transactions per minute and new orders per minute on the host side. So those are Oracle metrics that we're analyzing there. And then on the storage sides, we're calculating other things like throughput and that on the storage end.
What was the performance that you saw out of the 9150 or the entire result in an Oracle environment?
Yeah, comparing NVMe to FCP, we saw an Oracle transaction per minute improvement of 24%. So that's just changing the protocol. Nothing else changes in the environment. So you get 24% improvement in performance. But more importantly was what happens to the host. It runs so much more efficiently that the CPU is 64% lower for the I/O being done. And the I/O wait time goes down significantly as well, like 24%. Combined together, the efficiency score is like 3.5x. So the whole system is running far more efficiently using NVMe over Fibre Channel compared to the traditional SCSI protocol.
I think for me that was the beauty of the whole test. What we did is we demonstrated how much better NVMe was than just running FCP. It wasn't about purely benchmarking the 9150. It was about showing how much better a workload runs.
Right, and you literally get, it's the same user experience as far as managing the fabrics. It's exactly what you're used to with Fibre Channel. So if you have professionals that know zoning and all, fabric services and name services and all that with the fabric, it all is exactly the same. As far as connecting to the storage devices, I mean, they get discovered exactly the same way. If there are changes on the back end, let's say you change the storage size, that gets reflected on the host automatically now. And of course, multipathing is available with ANA support. So you have absolute parity between the two protocols these days. So
And of course you have the ability to run existing protocols with NVMe across the same switches to
over the same wire
HBA.
at the same time. Yeah, it's amazing. Yeah.
It sounds like the NVMe performance is rather significant. How important is the network or the network speed? Did you see any difference because you ran both 16 gig as well as 32 gig Fibre Channel?
Right,
Did you see
yeah.
any difference as you did
We
that?
were real thrilled. The array has a 32 gig interface on it. So if you have a SAN fabric that's 32 gig, it's a good reason to upgrade to one. And the host, of course, will have a 32 gig HBA. Running a data warehouse workload on this with Oracle 12c, we saw the data warehouse query times drop in half. So it takes advantage of every bit of that extra bandwidth available with 32 gig. So we can see that in the real world.
So the network interfaces do matter, both as well as the storage
Significantly,
array
for sure.
through the network all the way back to the server.
Yeah,
the
For
adapter.
sure.
So in setting this test up, I believe it was at the Washington System Center that IBM provided, correct, in Virginia?
Yeah, that's right.
As you were setting that, you were essentially Oracle admins and storage admins for a week as you put this together. What sort of benefit is someone going to see in the field if they're actually an Oracle administrator or a storage administrator?
That's a good question. There's so many benefits to NVMe, probably the biggest one being the host side efficiency. It lowers CPU utilization quite significantly. The side effect of that for an Oracle admin is, if you're using less CPU, you can use less processors or lower speed processors to do the same amount of work, which in turn entails that perhaps licensing for Oracle licenses are cheaper because there's less cores involved. Also, less power is consumed in the data center, and as a result of that, it could be some benefits to heating and cooling costs as well.
Well, I'm sure people believe what you say, but I'm sure they'd also like to read the ESG paper that's going to be coming out soon. I'm sure there'll be a link here in the bottom for you to download it. We highly encourage you to do that, and thank you again for your time, and I appreciate you guys doing the real-world test.
Great.
Let everybody know the performance of NVMe as well as 32 gig in the environment. So thanks again.
Great. Thanks, Greg.
All right. Thank you.